All right, here we go. This is Macy and Owen and who else? Is that it?
Are we? Oh, we're doing example.
We're doing example 3, so you guys are backtracked. Okay, this is 2-5. There's a homework assignment for it. Stay quiet. So let's do example 3. I know that we did this on Friday, but I'm going to actually plug in pi over 4. I'm going to show you how this works, okay? We need to do the second derivative, all right? So we're taking the first derivative of secant. That would be just f prime of x, and they tell me the derivative of secant is secant tangent. That means secant times tangent, right? So secant of x, tangent of x, okay? Keeping in mind, be quiet. Give that to me. Good Lord. Okay? Keeping in mind that the x is trapped inside of secant, the x is trapped inside of tangent, okay? And there's like a multiplication symbol in between these two. Got it? So now, when we go to do the second derivative, we have to use the product rule, right? This is a product. So here is f and here is g, yeah? All right, f prime g plus g prime f. Do we have that memorized yet?
Yes.
Yes, okay. F prime is the derivative of the f. What's the derivative of secant?
Secant times tangent.
Secant x, tangent x, right? We just did that one, okay? What's the derivative of tangent?
Well, you aren't doing the derivative.
Oh, right, we're not doing the derivative of tangent. It's just tangent. You're right, I lied. Plus, now we're doing g prime, the derivative of tangent, which is secant squared.
Yes.
Okay, x. And then f is just secant of x. Secant x. Okay. And then we simplify any way that we can. So here is secant x tangent squared x plus secant cubed x.
Can we
Right? We've got that going on.
Yeah, we pulled a secant out.
Yeah? We pulled a secant out. Yeah, let's go ahead and do that. Sure. Secant x, and then we've got tangent squared x plus secant squared x.
Yeah, I just don't know how far we go. Like, it's like that's what I'm like.
I will take either one. Like, if you leave it like this, that's fine. If you leave it like this, that's fine. We have to decide what the best way to do this is. We are plugging in a pi over 4. So, like, we've got to kind of, like, weigh the pros and cons and figure out what the easiest way to do.
I'm gonna be the top.
Okay? So, we're plugging in pi over 4. So, this is what we're doing. We're doing secant of pi over 4. Okay? So, this is where you commence now. We are to this point. Tangent of pi over 4. Start writing this down. Plus secant squared of pi over 4, right? This is where we're at now.
Yeah.
Oh.
Okay.
So.
Oh, this is when you use the units.
Now we're going to use the unit circle to do this, okay?
Well, why do you need the unit circle? Just plug it in the calc.
No.
I mean, you can, but it won't give you the right answer. You need the unit circle.
So wacky.
You trig kids don't quite know how to use the unit circle yet, but you will, so I'm just going to kind of glaze over this a little bit. If you have your unit circle, did we get that written down?
Like a donut?
All right, here we go. This is the unit circle.
It's level.
On this unit circle, there is sine, cosine, and tangent. Everybody listen real quick. Shh. Sine, cosine, and tangent are built into this unit circle, so it's basically like you have access to all of the stuff on a calculator, but you don't have to use a calculator. So let me show you. Pi over 4 is this guy right here. He is 45 degrees, all right? Now, cosine is the x-coordinate. So if I'm trying to find cosine of pi over 4, it is the square root of 2 over 2. Your calculator will round it off as a decimal, which makes it that much more inaccurate. True? The sine value is the y-coordinate. So sine of pi over 4 is the square root of 2 over 2 as well. Yes? What is tangent of pi over 4? 1. Tangent of 45 degrees or pi over 4 is 1. So every single sine, cosine, and tangent is all on this thing. Like if I'm looking at 210 degrees or 7 pi over 6, cosine is this guy, sine is this guy, tangent is this guy, right? I can figure out what those are. It's basically like I have access to a calculator, right? Okay? So we're looking specifically at pi over 4. So remember these guys, square root of 2 over 2, square root of 2 over 2, and 1. Yeah? Okay, so here's the deal. If I go down here, I am trying to find secant of pi over 4. Wait a second. Secant wasn't on the unit circle, but
Use your blue sheet.
kind of. No, blue sheet just has derivatives, okay? Secant is 1 over cosine of pi over 4, right? Okay? That's what secant is. Okay, now, what's cosine of pi over 4?
2 squared.
The square root of 2 over 2, right? Okay? So what's 1 divided by the square root of 2 over 2? Keep flip. 2 over the square root of 2. That's what he's going to look like. And we're not going to rationalize yet. Okay? Good? Times tangent of pi over 4 squared, right? What's tangent of pi over 4? 1. And I want to take that guy and I want to square it. So that is just 1 plus secant, like secant squared of pi over 4 is secant, this means secant of pi over 4, that whole thing squared, right? What's secant of pi over 4? How do I find secant of pi over 4?
2 over.
1 over
Well, we already did this.
cosine of pi over 4.
Oh, we already did
Okay, and I want to take that thing and I want to square it. So cosine of pi over 4 was the square root of 2 over 2. 1 divided by the square root of 2 over 2 is just
this. No, 1.
2 over the square root of 2. And I want to take that and I want to square it. All right, how do I take 2 over the square root of 2 squared?
It's
Square the top and
4
2
over
squared is 4. The square root of 2 squared is 2. So 4 over 2 is 2. And 2 plus 1 is 3. And 3 times this guy is 6 over the square root of 2. Or if I rationalize and I take it times the square root of 2 over the square root of 2 because I don't want the bottom to be a square root, right?
slide back over.
This is 6.
Wait, one guy. Wait a minute. What the heck?
Do we need to get caught up?
I
Was that a lot?
I
All
don't
real quick.
understand
It is
all
a
this
lot, but
secant
we're just-
stuff.
Did you understand how we got to that point? Okay, secant of pi over 4. I don't have a secant on my unit circle, so I do 1 over cosine. So cosine of pi over 4 is square root of 2 over 2. And 1 divided by that just flips him, right? So now I have the square root of 2 over 2 squared, which is 4 over 2, which is 2. And 2 plus 1 is 3. And 3 times that is 6 over the square root of 2. Are we good so far? Kind of, ish. If I multiply this through, what's 6 times the square root of 2? 6 square roots of 2. What's the square root of 2 times the square root of 2? 2. And that I can reduce those 2, which is 3 square roots of 2. That is the final answer.
Chad.
That's
Hold
insane.
on. Wait.
That's
So
insane.
when we need this in real life.
We're going to do a story problem here in just a second.
Drawings, and you're trying to get this.
Just wait. We're going to do a story problem here in just a
Yeah,
second.
because I need to know
Hey,
the
yo, guys,
angle.
it's raining. It
Hey,
is?
that means we won't go to.
Woo! Okay.
God.
All right, here we go. Now we got a story problem. Listen. They drew a picture for us. And let's see what we've got. We have this angle. Shh. Here we go. Listen. Listen, listen. Listen, listen. Here's our flagpole, and the amount of the shadow is represented as S. That's the shadow length. The angle to the sun is theta, and then the flagpole is 50 foot. Okay? Really quick, before we read too much into this paragraph here, let's find a way to relate all three of those things. So we have an angle here, we have a side here, and we have a side here. Okay? Okay, we have opposite and adjacent, which is tangent. Tangent of what? What goes inside of the tangent?
Angle.
Theta equals, opposite is 50 over adjacent is S. Okay, so we've got that going on. Yeah, yeah? Okay, now, this is the equation that we're going to be using, and let's read the paragraph and see what they want. On a sunny day, 50-foot flagpole casts a shadow. The elevation of the sun is theta. S is the length of the shadow. Find the rate at which the length of the shadow is changing. Shadow is. I want S by itself on one side of the equal sign.
Rate at which it changes.
I want the shadow to be by itself on one side of the equal sign. So how do I get this guy by itself?
Switch it.
I'm going to switch them. S is equal to 50 over tangent of theta. Yeah? I want shadow is. I want the shadow to be by itself on one side of the equal sign. Okay, now it says find the rate at which it's changing when theta is 45.
Is that S or a 5? I can't tell.
This is a 50.
It's that woman handwriting.
Yeah, sure.
Rate of change.
No, on the
Should
left
I be able to
side.
read it?
On the left side? What are you talking
I know
about?
it doesn't say
This is an S.
So,
This is an S. The shadow, because I put the shadow over there.
The theta equals 45.
Okay, now, hold on, real quick. They said theta is 45, but we have to take the derivative first before we plug in 45, because is the angle going to change when the sun moves?
yeah.
Yes, so we have to take the derivative first of this thing. I want to find the rate at which this thing is changing, and that's derivative. Okay, so when I'm trying to find the derivative, how do I find the derivative of 50 over tangent theta? Quotient rule. Quotient rule. This is F, this is G. Okay? So we want F prime G minus G prime F all over G squared.
Kind of hate this.
Okay. All right. What is F prime? What's the derivative of 50? 0 times G is tangent theta. Oh, you want the bottom? Tangent squared theta? That's what he will look like. Okay? Now, f prime is 0. That's going to knock the whole thing out, but I went ahead and wrote it anyway, right? Okay, minus, what's the derivative of tangent?
I don't know.
It's
Oh.
squared x.
Secant squared theta, okay? Times f, which is 50. Okay, now we're going to simplify. The 0 knocks the tangent out, yeah? So on the top, what do we have? Negative.
Secant squared theta.
I'm going to go negative 50 secant squared theta. Can I do that? I like to put my
Fancy
thing
guy.
first, okay? Tangent squared theta. There is that.
Simplify.
Plug in 45.
No, dude.
Yeah.
Okay,
Divide
now
by
we plug in
50.
45, but hold on just a second. Hold on just a second.
We gotta get rid of
Real quick. Real quick.
Divide negative-
Real
divide by
quick.
theta.
Secant
Okay, I have a question. Oh, it's not. So
tangent
why
is sine over cos. Yeah. Here's what I'm going to do. Ready?
Sine.
Ready? I'm going to make life simple. I'm going to make it really ugly, and then I'm going to make life simple. Ready? Secant is 1 over cosine. Yeah? Okay, so real quick. This top is negative 50 over cosine squared theta because secant is 1 over cosine. Do you see that? Okay? Over tangent on your little unit circle sheet at the top left corner. I think. Nope. Top middle. Top middle. Tangent is how much? Nope.
Tangent of 45.
What is tangent equivalent to on your unit circle? Tangent is
4.
sine over cosine.
Where's that at? Why are we doing this?
I see tangent is equal to 1 over cos.
Tangent is sine over cosine. It's in the middle of your unit circle.
1 squared is 1.
Tangent is sine over cosine.
Where?
Right in the middle.
It's not in the middle.
Literally in the middle.
Can I
Right
do
here.
it my way?
Literally in the middle. Right here.
Middle
Tangent
down.
is sine divided by cosine. So tangent squared is sine squared divided by cosine squared. Okay, now, the reason why that, now you can plug this in. If you wanted to, go back to the pink and you can plug that into your calculator all you want, whatever. I'm going to make life easy. Ready? If I keep flip this, times cosine squared theta over sine squared theta, what happens?
Cancel.
Cancel. So final answer before I plug in.
Sine squared theta.
Now, Megan says there's no way I would get that. Can you get to this pink?
Yes.
Then just plug it in. But the only problem is you don't have secant. Now, you can plug it into your calculator. That's what I'm going to do. Actually, that's not what I'm going to do. I'm not going to do
How
that.
come it's not in our calculator? How come they don't make something for you?
You can type it into your calculator, but the calculator is going to round it
Okay,
off.
I have a question,
Yes.
right? So, why is sine theta times sine theta? Why is that sine
Hey, now
squared
you have
theta
to.
and not
Now you
sine,
plug in 45.
sine theta squared?
Because you're multiplying the signs together. You're not multiplying the x's together.
It's 1 over cosine.
So it's like
And
f of x
cosine
squared would
45
be.
is-
Now you have to.
Are you
plug in
leaving?
45.
Okay.
I gotta get my.
Okay.
I'm
Okay,
just
goodbye.
gonna watch some Chinese
Okay.
guy explain it on YouTube.
All right, anyway. You can go back to this guy and type him in here, whatever, if you want to. I don't care. Okay? But let's go here. What are we plugging in for theta?
45.
45. Okay, here's what I want you to do. Grab your calculator. Do you guys all have scientific calculators? The mode that you want to be in. Listen. The mode that you want to be in is degrees, because 45 is degree. Okay, so here's what you're going to do when you type it in. First of all, go to mode and make sure you are in degrees, because we're typing in 45 degrees. Okay? 45 degrees. Okay? Then you're gonna go negative 50 divided by sine of 45 squared. Okay? Or sine of 45 times sine of 45, whatever.
Where's my
Is
sine
it
button?
negative 1.57? Is it?
Is it negative 1.57?
How does it become? Why is it a negative number?
Okay, hold on.
Because the sun is going down.
Because the shadow is decreasing at a rate of 1.57 feet per
Negative
second, or feet per
100?
hour, or whatever it is.
I got negative
Hold on.
100.
Call me.
I know what you did.
you?
Are you?
You
mode?
can't put the
Degrees.
square on the
You
outside.
are in degrees. Yep. Okay.
It's negative 100.
It is negative 100.
Retard.
What?
Read up.
Hey, don't go there.
What did I?
No, I was calling try to
Negative 100.
Now I got negative 69, so I don't know. Bam.
Okay, you want the square to be on the outside.
I'll be honest, I still don't know what
And
I'm
I'm going to square.
I'll be honest.
I just
Whoa.
plugged in right now.
Because you are in radians.
Nah,
Only not the
that is
No.
not fun.
3 days of cookie clicker was not
There
the
you go.
plan.
Negative
It
100.
was
Okay.
long last.
All right. So, woo! As ugly as that was, what did we find?
You're next, buddy.
You're slow.
Find the rate at which the shadow is changing in feet per degree. So it is changing 100 feet per degree for the shadow.
That's a lot of feet. Okay,
Yeah, that is a lot of feet.
How can that be negative?
Because the shadow is
goes
getting
down.
shorter instead of the shadows getting longer. Yeah. The shadow is getting shorter.
Like nodding to what she's saying.
All right, let's go to example 5.
Hold on. So in this, the sun's like going up to be 90 degrees. Right?
Correct.
All
The
right.
sun is going up,
Okay, that makes
which is making the shadow shorter. Yes. Okay. All right, let's go to example 5. We have a spring, and the spring is doing this.
This is physics.
Assume the position function of the spring is doing one of these. Cosine, my trick kids, you guys don't know this yet, but negative cosine. Megan and Remington, do you remember what negative cosine looks like?
Oh, it's vertical.
It should be down. Then
It should be down, and then up, and then down again. Okay, this is the path that the spring is taking,
Knob.
right? So the spring is being pulled down, right? Then it's being released, and it's doing one of those, right? That's what the spring is doing, okay? Down to 3 past whatever equilibrium is. 3 what? 3 centimeters. It's stretched 3 centimeters beyond resting position. So it's down 3, right?
Like an inch.
3 centimeters down. Yeah, it's like a little over an inch, right? You're just pulling it down, and it's springing up and down and up and down and up and down. Okay, that's what it looks like, all right? They want us to find the velocity
No.
and discuss the motion of the mass.
Think about it. It's like
They want us just to find the velocity at,
you have the weight and you put a marker. Take it to the
I don't know. We don't have to find the velocity at a certain point. Okay, the position function is s. Velocity is going to be the first derivative. Okay, so that's all we have to find. S is negative 3 cosine of t. Cosine of t. And they want us to find the derivative, which is going to give us the velocity. Okay? All right, how do I find the derivative of negative 3 cosine of t? What's the derivative of cosine?
Product.
like the paper moves.
The derivative of cosine is what?
Up and down.
Cosine over sine.
Sine. Negative sine.
Negative sine. Okay, so what's the derivative of this whole thing?
3 sine.
Positive 3 sine of t, right? Okay? This is going to tell me what the velocity is at any point in time. So let's say I want to know, let's say I want to know 2, because we just found the derivative. The derivative of cosine is negative sine. Okay?
Wait.
Let's say I want to know what the velocity is at 2 seconds, right? I'm going to plug 2 in for sine, and that's going to tell me how fast that thing is going. Now, I want 2 to be in radians, not in degrees. We'll talk about how you know that is, okay, later on. But I want 2 to be in radians. I'm going to plug 2 in for radians.
Why?
Okay.
Wait, what's the difference?
Radians are the amount of times it goes around the circle.
Uh-huh.
The mode button.
Mode.
Go to mode and go to radians. Okay?
It was probably.
So 3 sine of 2.
Radians because we reset it.
Uh-huh.
2.7.
2.7.
2.72, and that is in what units?
What? Wait.
Centimeters per
Second.
second.
3 sine.
At 2 seconds,
in
it is
radians?
going
Or in degrees.
exactly 2.72 centimeters per second
3.
I don't understand the difference.
for a velocity.
2.
Now, that is assuming that what's happening?
Degrees is on a circle.
Everything's
radians
perfect.
is-
Everything's perfect. There's no friction. It's going to continue to oscillate forever, right? Which it
Because
won't,
1 radian is
because it's
like-
going to slow down, right?
takes to do this
But
or something.
if that would continue to oscillate forever, it would be going 2.72 centimeters per second at 2 seconds. Got it? Weird things. All right, there you go.
I don't like that. I don't get it.
Okay, work on those 7 homework problems if you haven't already done so.
Okay, can you fix that?
Yeah.
Sure, I'm doing this right.
Yeah. I will come help you if you have questions, but do those 7. Do those 7. Beautiful. Goodbye.
How many have you done?
I'm on 23.